co-sponsored by the Mars Society and the Planetary Society, and the Association of Universities for Research in Astronomy is also doing that and providing the food. Thank you. And to thank all of you for turning out to listen to what we have to say, and for the interest that you've expressed in this subject, because this is an extremely critical subject, and which is going to matter a great deal for the long term. And with all that else that has been going on right now, if you're in abroad, it's easy to get distracted. But once again, thanks for keeping your eye on the ball and now. All right, so we have 4 speakers who I'll just mention briefly now, and then I'll give more lengthy introductions to them as they come up to speak. And they will each give relatively brief comments of 10 to 15 minutes, and then we will have plenty of time, about an hour, for questions and answers from people from the floor here. There's also handouts available that go over a number of points, both the paper list of bullets, maybe points made here, and also there's copies of my book, which is available for free. It's unique. So you're special. Okay, so I'm Robert Zubrin. I'm president of the Mars Society. I'll be chairing the event. I'll be speaking last. Okay. We also have with us, and that's a bit more introductions. We have Jim Bell, who's the president of the Planetary Society and one of the principal scientists on the Mars rover mission. We have Heidi Hammel, who is an astronomer with the Space Telescope Science Institute. And we have Scott Hubbard, who is the former head of NASA Ames Research Center and the former director of NASA's Mars Exploration Program. So me, Robert Zubrin. I'm president of the Mars Society. I'm also president of a astronautics R&D company called Pioneer Astronautics. Got a doctorate, 25 years aerospace experience, 9 patents, 8 books. Okay, and that's it. Okay, so I'm going to talk a little bit about why I think this is important, and go over a little bit my views on the situation respecting these planetary and space astronomy missions, and then also make some points vis-a-vis the situation in the manned space program as well, and then try to pull this all together a little bit. And after that, we're going to have plenty of time for questions from all the speakers who will come up and have a panel. Okay, so let's start at the beginning. Western civilization is based ultimately on a proposition, Greek philosophy, Socrates, that there is a fundamental capability in the human mind that has the ability to distinguish right from wrong, justice from injustice, truth from untruth. And this idea was taken out of the academy by the early church and made a general societal idea in the form of the notion of the conscience, which is an idea that has the same word, that has the same root as the word science. Okay, it has to do with knowing the truth. And this is fundamental to all of our values, reflecting personal morality and justice and intellectual activity. To thine own self be true. We hold these truths to be self-evident. Seek the truth shall set you free. And science is the search for truth in the universe. And we need to do this search. You know, there was our knowledge of the universe, we've learned a great deal, but there's plenty we don't know. There's plenty, a lot of, you know, you go to school and they teach you, here's the laws of electromagnetism and gravity and this, but if you go down one level, there's lots to be explained. Matter cannot be created. Well, here's some was created. Electrons, like charges repel. How come electrons don't blow themselves to pieces? Okay, what's holding them together? order can only go to disorder, well then how is order created? How is life created? Okay, these things are unknown. These are great unknowns. Now, we found out a lot. Okay, we certainly have found out a lot. There was a time when people didn't know why things fell. Okay, but then in astronomy, Johannes Kepler, okay, came along, and by studying the motions of the planet Mars, okay, figured out the laws of planetary motion, put them in mathematical form, rational form, okay, which then worked on a little more by Isaac Newton gave us the laws of gravity. Okay. You know, there was time, I mean, in the 1890s, the head of the U.S. Patent Office said we should shut down because there's nothing really important left to be discovered. We know the laws of mechanics, we know the laws of chemistry and electromagnetism, that's all there is. Except with the laws of science as then understood, you couldn't explain the existence of the sun. And by studying the sun, we learned about nuclear fusion. Okay? And then astronomers. Okay? The first Hubble, the astronomer, okay, saw that using telescopes, saw the universe is expanding, and the radio astronomers confirmed this and said, gee, the universe is expanding, that means it had a beginning. How did it begin? Okay, you hear about the Big Bang, sounds great, but as currently understood, it's an event without a cause. We still don't know how that happens. And then the second Hubble, the Hubble Space Telescope, discovers that the expansion of the universe is accelerating. And that is a development that cannot be explained by the laws of physics as they were taught when I was in graduate school, which wasn't that long ago, and which is still being taught, as far as I know. They still teach laws of physics that cannot account for the acceleration of the expansion of the universe. Okay? So, we don't know how it began. Okay? We don't know what makes it go. When we put up the web, look deeper, look further, find out more how this thing began. I mean, what are the real laws of the universe? We want to go to Mars. We want to find out how life began. There's, I mean, really, in life as we see it on Earth, there's this enormous gap between chemistry and life. They're separated by light years of complexity. There's no anything in between. You cannot explain the origin of life from what you see on Earth. Maybe we can find it on Mars. Maybe life on Earth came from Mars. It was transferred here. We can find the intermediate steps there. We can find free living organisms more primitive than bacteria, which you can't find on Earth. Okay? Maybe we can sort it out. So we've got this program, and this is a magnificent program. It is a magnificent celebration of our society's most fundamental and deepest values. Okay? It is, I mean, you know, you can go and you go to Europe and you can see the paintings and sculptures, you know, Michelangelo and Leonardo da Vinci and the other Renaissance figures. Well, 500 years from now, they're not going to look at our paintings or sculptures, okay? The Library of Alexandria, but they all actually pale in comparison to this. You know, and so we can't desert this. And now, look at this, okay? There's talk of doing so, okay? It's not put in that way. But, look, we had a Mars campaign underway since 1994, okay, when Administrator Golden, after Mars Observer said, okay, this is how we're going to do it, advised by all these hundreds of committees and so on. But he said that's how we're going to do it. We're going to have missions to Mars every 2 years, an orbiter and a rover, or 2 rovers or something, and they put it together, and Scott organized it for the last decade, and this has been an extraordinary success. Okay, and we deviated from it a little bit with the Mars Science Lab because they made it a lot bigger, so we're using up 2 of those opportunities on this one. Okay, fine. All right, fair enough. But, hey, we had a 2016 mission plan and a 2018 mission plan, and now they're off the books. Okay, and that essentially ends that campaign. Okay, and also also, as Scott mentioned, it destroys our ability to be reliable collaborators with others who are willing to sign up and join us in this campaign and join their efforts to ours and make it a much better campaign than it would have been before. Okay? And the other outer planet mission, the Europa mission, boom, gone. Okay? So all the missions that were there are gone. So yeah, it's possible that in the future someone might restart our planetary program, but right now the queue is empty, a situation we have not had since Sputnik. Okay? The queue is empty. So yes, we have the appearance. For a while, people won't see it because there are missions. It's got Opportunity and the MRO and even Odyssey are operating on Mars right now, and the Science Lab is on the way. And we even have Maven for 2013. It's almost completely built. But these are legacy missions. These are missions that were started by previous administration. Right now, we're not planting any seeds. No seeds, no harvest, no missions, no program. Okay? And the, so, you know, it's like Apollo. As the Apollo astronauts are coming back from the moon and the nation was celebrating and, you know, having the ticker tape parades, the administration then in charge was basically destroying the entire basis of the program, and they're shutting down the Saturn V lines and the lunar landers and all this. They're all going away. So even as people saw good things happening, the prospect for continuation was being aborted.